This is Ben from Testive, and we're looking at an SAT Heart of Algebra question, testing you on coordinate geometry. The graph of a line in the xy plane has slope 3 and contains the point 2, 4. The graph of a second line passes through -1, 3 and 3, 1. At which of the following points do the lines intersect? So we have two lines, and we know that they're going to intersect, and we're supposed to find which of these points works for their intersection. So what we need to solve for is when the first line, we're going to put them both in slope-intercept form. We're going to solve for when the first line, y equals m sub 0, x plus b, is equal to the second line, which will be y equals m sub 1, x plus c. First thing that we need to do is solve for the slope-intercept form of each of these lines. So what we can do is we know that the first line has a slope of 3. So we can start off with line 1 as y equals 3x plus b, and now we can solve for this intercept b by plugging in our point 2, 4 for x and y, because we know it goes through that point. So we can say 2 equals 3 times 4 plus b, which is, we can say, I mixed up my x and my y there, so make sure you don't do that. We can actually say 4 equals 3 times 2 plus b, which is 4 equals 6 plus b, or b equals -2. Now we take this value for b and we plug it back into our equation. So y equals 3 times negative 3x minus 2. So that's our equation for line 1. Okay? Now, what we're going to do is solve for our second line now. So we're going to have y equals mx plus c, but we don't actually have any of these values yet. What we do have is are 2 points that the line goes through, -1, 3 and 3, 1. Now remember that slope is just rise over run, so you can subtract the y values, y0 minus y1 over x0 minus x1, to get the slope of a line. So we can take the y values, 3 and 1, this one and this one, can say m equals 3 minus 1 over the x values, -1 minus 3, which is equal to 2 over -4, which equals -1/2. And now we plug that in. So we have y equals -1/2 x plus c. And now we solve for c the same way we did the last time. Plug one of these points in, so we get 1 equals -1/2 times 3 plus c, which is the same thing as 1 equals -3/2 plus c. If we put this into halves, we're going to get that it's c equals 5/2. So now we have our equation y equals -1/2 x plus 5/2. Okay, and that's line 2. So now we need to solve for setting these equations equal to each other. So we know that we can actually set, we know that we're looking for where they intersect, so we can set these equations equal to each other. So we can set 3x minus 2 equal to -1/2 x plus 5/2, and we're going to get, let's see here. Well, let's pull our x's together. So let's take 3x is the same thing. We need common denominators. So let's say this is 6/2 x plus 1/2 x. So I'm just moving 1/2 x over. and I'm going to move -2 over, equals 5 halves plus 2, which is 4 halves. So now we have 7 halves x equals 9 halves. That would be, let's see, that's 7. If we multiply both sides by 2, we're going to get that 7x equals 9. And therefore x equals 9/7. Okay, sorry, I'll make that a little more visible. X equals 9/7. Now, is this only in one of our answer choices? Yes, it is. So therefore, we could stop there, and we could just choose this answer choice. But if we want to double check, what we'll actually do is plug 9/7 in to one of our equations and solve for y. So we would get y equals 27/7 minus 2, which would be 14/7, which equals 13/7. So now we know that it's 9/7, 13/7. Okay? So you found the slope-intercept form of each line. You set those forms, equations equal to one another. You set those lines equal to one another to find where they intersect, and solved for the variables x and y.